In this video, I will be continuing the compute shaders in ModernGL series, where I teach you how to make compute shaders in ModernGL. Now, for this video, I'm going to be generating random numbers from the GPU. So, yeah, to get started with generating random numbers, we don't really need an input, right? Because we're generating the numbers ourselves, so from the GPU. So we don't need an input for the buffer. So we can just delete that data line and we can say n equals, let's say 100 numbers. Like this is how many numbers we're going to generate. So we're not going to use this data.2 bytes obviously because there is no data variable. Instead, what we're going to do is there is a keyword called reserve that will just reserve how many ever bytes you add in the VRAM of the GPU. So if I were to say n here, this would reserve 100 bytes, but let's say we want to get a random number. Let's say we want to get an integer as a random number. So let's say we want an integer, a 32-bit integer, which would be 4 bytes each. So we would have to multiply this by 4 because if we simply say n, then we are assuming that all of our numbers consist of 1 byte. But since we're using an int32, which one number is 4 bytes, so we have to multiply n by 4 because, well, math. And then over here, instead of the number of work groups we want, instead of that being 100, we'll just say n. And lastly, for this main.py file, our D type is F4, which is a float for it. It's a 32-bit float. But we want an integer, right? Because we're working with integers here. So we're going to say np.int 32. That is all for main.py. Let's go to shader.gl. Here, I want to first of all change this buffer name from input. I want to say random numbers because just so it's more self-explanatory. And then I just deleted that float array line, or the definition of the array. Instead, what we're going to do is we're just going to say an int array. We're going to create an integer array, and let's just call it random numbers. And it's an array, so we need square brackets. And we can delete this line in the main function. And what we can do is we could just do this. We could be like random numbers of I equals. Now, if we just put I here, that won't work because random numbers is an integer array, but I is an unsigned integer. So we have to we have to turn I into an int. So now if I say python main.py, it will get this basically because what we're doing is we're dispatching this many work groups. We're dispatching n work groups, and those work groups, for per work group, there's just one thread for now. Obviously, you want like 32 threads or 64 threads per work group in an actual compute shader scenario. But since I'm just explaining it here, we have it set to one thread. So what this means is we're getting the in global invocation ID dot x, which means it's getting the thread ID in the global scope. And what that's going to do is we're going to set random numbers of I. So let's say we're executing the first thread right now. So I will be equal to 0. So random number 0 will be an integer because it was an unsigned integer, but now it will become an integer of 0. That's why you have here at address 0 you have, or not address, at index 0 you have 0. And then let's say you're on your thread number 1. Let's say thread number 1 is executing, so you'll have random numbers 1 equals an integer of 1. So that's why you have this here. So obviously I could print, I'm just printing 10 here from the last video, but you could print all 100 of them. And you'll get something like this, just counting from 0 to 1 or 0 to 99. But I'm just going to change that back here. But that's not really a good random number generator. So what we're going to do is define another function. We're going to call it just say int random, or we'll say int generate random number. And then what we're going to do is we're going to just taken uint. We're going to take the seed as an argument, and then we're just going to do some mathematical operations or logical operations, whatever you want. So we can just do like seed, I don't know, XOR equals like seed shifted left 14. Shifted left means it just shifts all the bits toward, this is shifted right. It shifts all the bits towards the right. That's all that means. And then we can say seed, let's say times equals like, I don't know, some random hex value like this. And then we'll do another seed XOR equals X shifted left like 16. And then seed again times equals some other random value. And then lastly we can say some other like seed. Now if we did division here, it would become a float, and then we have to convert that back to an int. But we, instead of doing that, we could do that, but it's just easier and a lot faster. Instead of adding another float conversion, I mean instead of adding another int conversion, we could just do hit this here instead of division. So now we can do like x shifted left 10, stuff like this. And then we just going to return seed. Okay, so actually x doesn't exist. That was in my other code. So instead of x, we're going to change that to seed. And then we're going to just return seed. Okay, yeah. So if we return seed, seed is a uint. So even if we do all these operations, it still remains a uint, an unsigned integer. So actually, but the function return type is an int, so we have to convert this to an int. So now you won't get any errors. So right now, we could run this. Let's say random numbers of I equals. We could do generate random number, and we'll pass a uint I as the seed, or you could obviously do like I times I divided by 2, something like that. Or you could even have a nested call, like let's say I generates the first, I is the seed and it generates another seed, and that goes into a random number generator. You could do something like that. But for now, if we go ahead and run this now, oh yeah, we get an unsigned. Okay, so I put too many numbers here. Yeah, so now we got some random values, right? And since this will generate a random number from the minimum value of 32-bit integer to the maximum value. So if we want to declare a range, like we want it from x to y, if we want to do that, then we have to create a normalized number function. So we'll say int normalize number, and that will take in an integer of number, obviously. And then we'll take int x, which is the minimum value, and then we'll also take int y, which is the maximum value. Here we'll say a float n equals, we'll convert all this to a float. So we'll just say float and we'll open some brackets. We'll say the number plus. So if our number is like, let's say the minimum value of an integer. So if we were to add to that the absolute value of the minimum value of the integer, that would bring us from 0 to the maximum value of an unsigned integer plus the minimum, the absolute value of the minimum. Basically what we're doing is, instead of going from the minimum to the maximum, which is an integer, we go from 0 to the maximum times 2. Almost you have to just subtract 1 on top of that. So that's what this is going to do. We're going to say, so the minimum value or the absolute value of the minimum value will be, I'll just copy it here because it's kind of a big number. So it's this, it's 2147483463648. And then we're going to just divide that by it's another number, which is the maximum of an unsigned integer. And this is the, we have to add this too, which is the maximum value of an unsigned integer. We have to divide it by that, and then we'll just return an integer, and will means integer and brackets. So we'll take a float of x, and then we'll add n, which we just defined here, and we'll multiply that by float of x minus or y minus x, like this. And then that should not give us any errors because we're not even calling the function. So it should assemble at least, or it should compile at least. Okay, so that's not giving us any errors. So now instead of this, if we were to, let's say, int random number, and then we'll say generate random number, and we'll pass I as the uint, c as the seed basically, and then we'll say random numbers of I will be the normalized number, and we'll say random number, and x is the minimum value, y is the maximum value. So if you want, let's say I want from 0 to 10, so now it should give me technically from 0 to 10. Okay, so I forgot to add a point 0 at the end because then it would have become an integer anyways. So it's not just this, you have to add a point 0 at the end of this big 429, just that number basically. And now you get, well, pseudo random numbers because it's giving the same output every single time we run it. Like this number is random from this number, but this entire list is the same as the next list which we just ran. So this is technically a pseudo random number. So since it's generating a pseudo random number, what we can do is like factor in the current time or something like that. We can go over here in or we have to do it here only. So we can be like let's say uniform, and then uint or int, or I'm just going to do uint, and then u time. That's all. And then over here we're going to say the, instead of I as the random numbers generator seed, we're going to say I XORed with the u time, just like this. And now what you can do is over here you can be in the before program dot run, what you can do is you can just say u time equals an integer. You have to do this, you have to go up here first and then say import time, and then you can say uint is an integer, and then we'll say time dot perf counter, which is just a more accurate version of time dot time basically. And then we'll multiply that by 100 to get, or by 1000 to get milliseconds. And then just before prog dot run we'll say prog, and then it's kind of like how you would access a dictionary in Python. So use square brackets and some quotes, and then we'll say u time. That will be just dot value. We have to specify dot value equals u time, like this. So now this should technically generate a different random number every time we run it. Or yeah. So I remove this again. So every time we run this, it is generating completely different numbers. But that's it for this video. And yeah, that's it for this video. And if you like this video, I have my own channel. I'll put a link to it somewhere on the screen here, where I'm currently doing an RL from scratch in Python series, which is reinforcement learning, and I'm using VPython for the visual stuff. But yeah, if you like this, then you should probably check out my channel. And yeah, that's it for this video. Okay, bye.